So some of you may recognize from the slide Plankton, which is a bad guy or a villain in a popular children's TV show. But in reality, plankton is very vital in our underwater environments and can be a key indicator of ecosystem health. So phytoplankton and zooplankton are small yet very mighty species. Phytoplankton produces more than half the world's oxygen annually, and zooplankton is a key link in the food chain, taking nutrients from the lower levels like phytoplankton up to the larger animals that we see at the top of the food web. Phytoplankton also produce omega-3 and omega-6 fatty acids, which are healthy fats that travel through the food web to the fish that we eat at our very own dinner tables. And these healthy fats are essential. So that means that we must get them from our diet because our bodies can't produce them either in enough quantities or at all. So what do you think would happen to plankton here if he experienced stress from the environment? Do you think, such as ocean temperature increasing or increasing acidification? Do you think his predators would still receive the same level and the same types of these healthy fats? Global climate change research shows our oceans are both warming and becoming more acidic, meaning all ocean life is fighting World War III in order to adapt. So my research quantifies these healthy fats in phytoplankton and zooplankton from the Canadian Arctic region. And I also look at the effects of temperature and ocean acidification on these differences in energy transfer. So in my preliminary results, I found that about 75% storage fats compose of the zooplankton samples I've looked at. And this 75% actually increases as I go further north. So in the region where there's a little bit cooler of a climate, I've found more energy stored. In my future research, I'll be looking at a different type of fats, which primarily compose membranes. So they're kind of a structural barrier that also allows regulation between two different areas. So plankton has undergone massive changes in his fat and fatty acid composition. And if these continue to change drastically, plants, animals, and us as humans can still be impacted. So this is my journey to find out if marine species really are what they eat. Thanks.